little about the OneOmics project and the launch today?
Sure, yeah, thanks Sarah. So I'm here with Jordan Stockton from Illumina, and OneOmics project is really a partnership between our two companies, between Illumina and AB SciX. And we started this about a year ago with the goal of really bringing together tools and an easier way to do systems biology and functional genomics. So obviously Illumina, the world's leading next-gen sequencing company, and AB SciX have the new next-gen proteomics swath technology. So the idea really here is to bring in proteomics with next-gen sequencing to get a really system-wide approach to research.
Okay, thank you. Jordan, can you tell us about Bayspace and how it helps your genomics customers?
Sure. One thing we're trying to do is basically take the biologist who has lots of questions that really transcend sequencing, include lots of data from lots of different types, and empower them to answer questions by themselves without the need of an IT department or a dedicated bioinformatician. So Bayspace was a software as a service product that eliminates the need for hardware and mostly eliminates the need for a lot of software setup and bioinformatics hard work. It makes very simple a sample to answer workflow in the cloud, and I think it's great that that same workflow can now be applied to genomics and proteomics data even in the same combined analysis. So we're really excited to be able to take the concept of Bayspace, which is around genomics, and expand it to what is an obviously integrative science that we see happening all over the place in labs doing proteomics and genomics together.
Great. And Aaron, now that we've been able to incorporate next-gen proteomics data into Bayspace, what will that mean for our customers?
So, when we started this, we'd taken our desktop software that already is kind of proteomics processing, but we didn't really just want to replicate that in the cloud. Although the cloud brings us a lot of processing power and storage and sharing of data, what we really wanted to do was try and make the whole of proteomics a little bit simpler for the biologists. And so the apps that we've got there are really 4 apps altogether. The first one is really the processing of the data, and that's up to about 50 times faster than you can do it on a desktop PC. But then really the visualization of this, and because these are apps, we've got a visualization app there, which really can look at, first of all, a heat map. With swath proteomics, you can look at thousands of proteins in hundreds of samples, and so to visualize those, that's really quite complicated. Heat map's the first kind of the opening page on the visualization, but then you can even look at all the proteins, the up and down regulation of proteins. And what's really unique about this is that although this is mass spectrometry at the back of it, you don't actually now see any mass spectrometry data in the applications.
Okay, and talking about the apps, can you tell us about those apps that we've launched this week?
Yeah, so as I said, there's the visualization app there, and for the traditional mass spectrometrist that wants to get more into the data, there is some analytics. There's the protein expression analytics, which can go into false discovery rates and things like that. But we've worked really hard behind the scenes on a lot of these algorithms to really get to a stage where this is almost parameter-free proteomics. So now, if you can run the data with swath, you can visualize the data, you can start to look at the up and down regulation of the proteins. But it doesn't stop there. We've worked with partners, ISB. They've developed an app on Bayspace as well, and so that app is really for a swath atlas to bring in some of the libraries. And Yale University have been real great collaborators here and started to look at how you can actually now not just do proteomics and transcriptomics and do that in parallel, but take it in a serial way and take the FASTQ file from transcriptomics data and convert that into a FASTA file and then do proteomics on that. So there's some really cool apps in there, and really it's a real environment for innovation as well. I guess we think that we don't have all the answers here really, and it's a good innovation platform for other bioinformaticians around the world to start innovating on.
Yeah. One of the things we've worked hard on with Bayspace is to provide a set of APIs and a development environment that anyone can go to. And if they're not a biologist end user, as I spoke to before, but an informatician who wants to add to the sort of tool set that the world has to analyze not only proteomics and genomic data, but potentially integrated data, there's a place that they can deploy and test and even get feedback from our growing customer base on what they're developing in real time. It not only adds to the sort of the level of richness of what we're doing, but it provides comparability of results and reusability of results that the bioinformatics community really hasn't seen. So we like to see this not only as a development environment for our project, but as a growing environment for integrated apps that look at genomics and proteomics and other types of metadata that are really necessary to be experimentally complete.
You got the Bayspace Developers Conferences as well, don't you?
Yeah, so we just finished one in Bangalore. We do a couple a year, and we get 50 to 60 developers together, and everyone who attends one of those finishes their own app. And at our last developer conference in Bangalore, we actually had a hackathon for expert developers to come and actually bring their own projects and discuss what they're doing inside Bayspace. So there's a burgeoning community of people who are actually using this not only as a tool to share data, but to share sort of algorithmic ideas in a development environment.
Yeah.
Okay, thank you very much. So it was Aaron Hudson and Jordan Stockton from the HUPO 2014 conference in Madrid. Thank you very much.
Bye.
Thank you.
Bye.